In general, when you are factoring, you want to go through these steps right here. First ask, can I factor out a GCF? Then you will count how many terms there are, and if there are 4, you will try the grouping method of factoring. If there are 3 terms, you will try unfoiling, or basically breaking it up into 2 different parentheses. If there are 2 terms, you will either try the difference of 2 squares, or you will try the sum or the difference formulas of 2 cubes. Then, after you have factored them, you will ask again, can I factor further? This is the most common mistake, where people get their answer down to 2 parentheses, and they don't look at what's left inside the parentheses and ask, can I break this down further? So please train yourself. And even more so, it's more important to just automatically, number 1, ask, is there a GCF? Because if you don't factor that GCF at the beginning and you don't catch it at the end, you will get marked wrong. Because anytime you are factoring, the directions really imply factor completely. Whether that word is completely or not written there, it is assumed. So now let's go through and do some of these mixed problems. In this first problem, I noticed that 2 is a GCF, and I can factor it out and have a squared minus 81. I noticed there are 2 terms there, and they're both squares, so that's the difference of 2 squares, and I can factor this as a plus 9 and a minus 9 with the 2 out in front. For this next problem, I noticed that 3 is a common factor to each term. So I'm going to factor that out, have q squared minus 3q minus 4, and then that q has no number out in front, coefficient, so I can factor this, if it will factor, into q times q. And then I just need to play around with this 4. I'm going to have a minus 4 and plus 1 if I'm going to have these middle terms, minus 4q and plus 1q, adding up to the minus 3q in the middle. And then I ask, can I factor further? And the answer is no. We don't have any common factors within each parentheses. For this next problem, I am going to rearrange this to put it in descending order, k squared plus 16k plus 64. That is not necessary, but I prefer to do it that way. I'm going to rewrite this as k plus 8 times k plus 8, and since I have the same thing in each parentheses, I can rewrite that as k plus 8 squared. Note that had you factored this into 8 plus k times 8 plus k and written this as 8 plus k quantity squared, those are really equivalent expressions because addition is commutative. For number 4, I notice that 5 is a GCF and can be factored out, and I have r cubed plus 1 left over. Then I say to myself, that's the difference of 2 cubes. That's going to factor into a plus b times a squared minus ab plus b squared. Hopefully you've got that memorized, and you can now write this as 5 times r plus 1, r replacing the a, 1 replacing the b, times r squared minus 1 times r, so r, plus 1 squared, which is 1. For number 3, we see that 3 is a prime number, so it would have to factor into 3y times 1y. We also notice that 1 is a prime number, and 1 times 1 is what we would have. But when you look at your inner and outer terms of 1y and 3y, there's no way they can add together to make a 1y. So this does not factor, and this is a prime expression. Notice I'm not talking about a prime number, we're talking about a prime expression that does not have any factors. For this next problem, it's got a leading coefficient that's negative, and I notice that p can be factored out. So I will divide out a minus p and be left with p squared plus 5p plus 4. Leave the negative p out front. That's a plain p squared, so I know if it factors, it will be p and p. And 4 times 1 is 4, and 4 plus 1 is 5, so I will have a plus 1 and a plus 4 in my 2 parentheses. For this next problem, I see that I've got a uv in the middle, so I'm going to have two variables to deal with. I don't have any GCF that goes into all three terms, so I'm going to have to break this into a trinomial and unfoil it. I notice that 2 is a prime number, so it's going to have to be a 2v and a 1v at the end of the parentheses. And then I've got to play around with how I break out the 14. It's either going to be a 1, 14, 14, 1, 7, 2, or 2, 7, and it turns out that the 7u 2u works because we get a 7uv on the outer and a 4uv in the middle, and if they're both negative, negative 7 and negative 4 make the negative 11uv that we're aiming for. For this next problem, I notice that 81 is a square and 25 is a square. So I'm going to just take a stab at this and hope that I have a binomial square using 9u at the beginning of each and a 5v at the end of each, and with that minus there I'm going to guess that both of these are negatives. Now before I move on, I'm going to check this. My middle terms are minus 45uv and again minus 45uv, which do add up to make minus 90uv, and so we do have a binomial square of 9u minus 5v quantity squared. For this next problem, yes, 3 is a GCF that can be factored out. We are left with 4x squared minus 4x plus 1. When we factor that further, 1 is a prime number and it's got to end in a 1, and maybe, just maybe, 2x and 2x will work, and that is the case if both of these are minus signs. If you check your middle terms, that all works out. So we have 3 times 2x minus 1 quantity squared. Finally, for number 10, I notice that t is a GCF that can be factored out. That leaves me with t cubed minus 8, which is a difference of two squares, or a difference of two cubes. I notice that they are the cubes of t and 3, and I can factor this into t times t minus 2, that should be a 2, times t squared plus 2t plus 4.